Let's explore the probability of a point landing in a shaded region. We start by calculating the area of the circle using the formula pi r squared. With a diameter of 16 feet, the radius is 8 feet, giving us an area of 64 pi square feet. The shaded region is found by subtracting the inner circle's area from the outer circle's area, resulting in 36 pi square feet. To find the probability of a point landing in the shaded region, we divide the area of the shaded region by the total area of the circle. This gives us a probability of 36/100ths, which simplifies to 9/25 or 36%. A probability can be expressed in fraction or decimal or percent. Now, let's consider a rectangular piece of stained glass. We need to find the probability of a random leaf landing in the trapezoid section. First, we calculate the area of the rectangle, which is 45 square centimeters. Then, we find the area of the triangle, which is 15 square centimeters. Subtracting these gives us the trapezoid's area of 30 square centimeters, leading to a probability of 2/3. Thank you for watching. Please subscribe to AB Math Education YouTube channel. Alternatively, we can calculate the trapezoid's area using a different method. By averaging the bases and multiplying by the height, we again find the area to be 30 square centimeters. This confirms our previous probability calculation of 2/3 for a leaf landing in the trapezoid section.